Hi guys, so today's topic is going to be application of ratio proportion. Now in this topic as usual, we are going to see the concepts that are related to this plus the questions. So this topic is ideally divided into two subparts. One part is partnership and the other part is mixtures. So let's first try and understand what exactly is meant by partnerships. So let's take an example. Suppose there are three friends ABC and they are starting a new business, and let's say they are investing 16 lakhs, 12 lakhs, and 20 lakhs respectively. And let's also assume they are investing it for 12 months, 8 months, and 6 months respectively. Now, there are total two types of partnerships that normally exist. One is simple partnership and one is compound partnership. So, what we need to understand here is if it is a case of simple partnership, then the ratio of profits and losses will only and only depend on the investment. Time duration has nothing to do with it. So, that means whatever is the investment ka ratio, same has to be profits or losses ka ratio. So investments amounts are in 16 lakh, 12 lakh, and 20 lakh. If we take the ratio, these are the numbers. And in the previous class of ratio, we have also seen that the ratios are always supposed to be reduced to the lowest possible form. So these numbers, after further reduction, will obviously be divided by 4 each of these numbers. So when you reduce them by 4, you get the answer as 4, 3, and 5. So clearly you understand. And if you also look at the numbers, C had the highest investment, which is 20 lakhs, and C also has either the highest profit or the highest loss among the three people. So what we need to remember, if it is a simple partnership, then the ratio of profits and losses will depend only and only on investment. But of course, probably this is not the real life scenario. In real life, the ratio of profits and losses will depend on both ideally, investment as well as time duration. So, if it is compound partnership, then the ratio of profits and losses will depend on both investment as well as the time duration. So, for this particular example, if we look at the numbers, then these are the numbers that we have. If we multiply their investments and the time durations, but now, since again they are ratios, so the suggestion is, and this is purely from calculation perspective, when you multiply them, they turns out to be quite big numbers, and because they are ratios, so you will want to reduce them further. And when you reduce them further, what ends up happening is that the calculation can be a bit tedious initially. So to avoid this entire issue, what we will ideally suggest is do not multiply in the first place. If possible, try and reduce the numbers right now only. So, for example, if we look at all these numbers, if we start reducing them, so obviously they both are, all these numbers are, rather we can say, divisible by 6, for example. So 6 twos are 12, again 6 twos are 12, and 6 ones are 6 basically. Then now what we are left with, all these numbers are divisible by 4, for example. So 4 fours are, 4 twos are, and 4 fives are. And now I don't think so any other number is possible to reduce from all these numbers that are left with. So now we will multiply. So 4 twos are 8, 2 twos are 4, and 5 ones are 5. So 8 is to 4 is to 5 is your answer when it comes to all these numbers basically. So 845, that's the ratio of profits and losses if it is going to be a case of compound partnership. So purely from the calculation perspective, this is what we can also remember. So this is the very simplest of the ideas. Now let's have a look at couple of more pointers also, which will help you to avoid a few things in terms of the mistakes that normally happen. So couple of notes basically we can say. So note number one, if nothing is mentioned about the nature of the partnership, then obviously we are supposed to assume it to be compound partnership because, as I said, this is the real life scenario. So if nothing is given, obviously you by default go ahead with compound partnership as the situation. The second note, which basically talks about, there is something called as salary, which is given to a partner or a business employee. So ideally, what is supposed to be done, that is the salary of the business partner or the employee is supposed to be subtracted from the overall profit first, and then whatever is the leftover amount, we are supposed to divide that in the desired ratio. Now, if you do not subtract that salary and directly divide the profit in the desired ratio, then of course that becomes a incorrect calculation. So, so hence the note, which is in case of an employee or one of the partner supposed to be given a salary, then first we'll have to reduce that or subtract that from the overall profit, and then divide the remaining profit in the desired ratio. So these are the couple of more pointers which will help you to avoid the mistakes that normally happen if you are not careful when it comes to partnerships. So that's the concept. Of course, when we solve questions, we'll understand more about it in terms of application and all those instances when it comes to partnerships. Now, let's try and have a look at another scenario, which is called as mixtures. The second part of this idea, basically. So they have tried to explain that with the question only straight away. So let's read it. It says a vessel contains milk and water in the ratio 3 is to 5. And when 6 liters of water is added to this solution, then the ratio of milk and water becomes 5 is to 9. And how many liters of the solution was present in the vessel originally? That is what they are asking. Now, there are three methods to be precise with which we can solve this. We'll at least try to see couple of them so that you are also well versed with the different thought processes. Now, again, we can take ideas or take help from the previous topic of ratio proportion, where we have done not exactly the same, but maybe similar kind of question. So when we say the ratio of milk and water is in the ratio 3 is to 5, it simply means that milk ka value is any multiple of 3 and water ka value is any multiple of 5, for example. And so that means we can do equations basically. So how do we form these equations? So to do the equation method, let's assume the values as, let's say, water is 5x because any multiple of 5, and milk is 3x, for example. And let's try and solve that. So for example, milk is 3x, water is 5x. We are adding 6 liters to that basically. So focus here basically. So milk is 3x, water is 5x. We are adding 6 liters of water additionally, so it goes in the water part. And then the new ratio of milk and water becomes 5 is to 9, for example. This is what they have said. Now we should be solving this. So let's cross multiply. So 9 threes are 27x. Then 5 5s are 25x plus 5 6 are 30. This 25x comes here, gets subtracted. So 27 minus 25 is 2x is equal to 30. Of course, x is 15 for that matter. But the question is not the value of x. The question is how many liters were present in the vessel originally, is what they are asking. So now if I want to find out what is the uh, solution present originally, what I will have to do is I'll have to stick to original ratio. And if you remember by any chance, the original ratio of milk and water was 3 is to 5, for example, which is what given in the data. So that is 3x of milk and 5x of water. So if we combine them, because we need solution, it becomes 8x originally. And x we know already is 15. So obviously 8x becomes 120 liters. So the answer of this question is 120 liters was present in the vessel originally. This is how we can solve this question using the first approach, that is equations. Now, of course, there are challenges here also, in the sense that if you are not able to form the equation correctly, then of course the answer will also be incorrect in the end. So it is very, very critical that you form the equations correctly. Now, the other method that we are going to look at to solve the same question is without any equations for that matter. Here we will use some different thought process which has 2 3 steps that you need to remember. So the thought process is very simple. We have to read the entire question one more time, and we have to find out what is the no change component. So when you do that, you will realize in the entire process milk has not changed at all, because it was water, because we added 6 liters of water. So the no change component is milk for us in the data. Of course, you'll have to read the question. According to that, the answer will depend. So make sure you are understanding that part correctly. So once we have identified the no change component, the component that is not changed basically, we have to make it equal. So if you remember, one of the milk was 5 and the other one was 3, and we have to make them equal, which means it should be LCM, and common multiple of 3 and 5 is 15, for example. Now to make this first milk 15, we have to multiply it by 5. That means we have to also multiply the water part by 5, because they both are in the ratio 3 is to 5. And we are supposed to make their ratios same, 3 is to 5. So if you multiply one part or one component by 5, the other has to be also multiplied by 5. So milk becomes 15, of course, but then water, the first water 5 becomes 25 parts, is what we can say, for example. And then the other one, the second milk is 5. To make it 15, we'll have to multiply by 3. That means we'll have to also multiply the water component by 3, because उन दोनों का ratio same रखना है, 5 is to 9. So the milk again becomes 15 as of the old value, but the water in the new scenario becomes 9 threes are 27 parts it becomes. Now, if you see, the milk has become equal, but you will observe one thing that has happened, that the water part has in fact changed, and in fact we can say that it has increased by 2 parts. Now try and think about this. Why do you think this water has increased by 2 parts? Because I hope you understand we added 6 liters of water from outside. And that is the reason this water is increased from 25 parts to 27 parts. That is, it is increased by 2 parts. So this 2 part of increase in water corresponds to 6 liters of water that we have added. And similarly, that means 1 part is half, which means 3 liters. And now they are again saying originally how many liters was present in the vessel. If you remember, originally milk and water ka ratio was 3 is to 5, but those numbers are not there now. The milk has become 15, the water has become 5 5s are 25. So vessel and solution is combining of both these two. So we can say originally there were 40 parts of solution present, 15 parts of milk and 25 parts of water. And we just now have seen that 1 part is 3 liters. So of course 40 parts becomes 120 liter, and we end up getting the same answer here as well. So method is completely different, which has no equations whatsoever. It is slightly a smarter approach where we are eliminating the equation. So I will again very quickly tell you the steps. The first step is identify no change components. It will be one component, sorry, and then you try and make it equal by taking LCM. And in the process, you'll see that the partner has changed, and then you simply compare why the partner has changed, and then you accordingly answer the question. So this is the idea behind mixtures. Of course, we have few more interesting things lined up at the question side as well, where we'll learn a few more new things also with the help of questions. But meanwhile, these are the few basic things that you want to understand when it comes to mixtures. So that's it, people. That's the concepts. Now let's move on and do the question. So starting with the first one, this is the first question which says A, B, C invest 40,000, 30,000, 50,000 respectively in a partnership firm, and at the end of 4 months, A quits basically, and then at the end of 6 months, B quits and A rejoins. Then at the end of 10th month, C quits and B rejoins. If profits at the end of the year is 1,14,000, find A's share in the profit. So clearly, since nothing is mentioned, we have to go ahead with compound partnership, and also the values of the investments are clearly mentioned, but it is the time period that is supposed to be considered properly, and for that we need to read it clearly. So at the end of 4 months, A quits, so A has worked for 4 months. Then at the end of 6 months, B quits. Okay, so B has worked for 6 months, and A rejoins. So A has come back for the last 6 months, because the duration is 1 year is given also. So effectively we can say A has worked for 10 months basically. Left after 4 months, came back after 6 months when B has left. At the end of 10th month, C quits. So C has worked for 10 months straight away, and B rejoins. So if you remember, B has quit after 6 months, and after C has quit after 10th month, B comes back. So B comes back for the last 2 months. So B has worked for 8 months and C has worked for 10 months. So this is how you are able to get the duration also right. So now you know their investments, you know their time period, multiply because it is compound partnership, and then find the answer, A's share in the profit. So this is what we need to understand here clearly. So these numbers, of course, when you multiply, can be reduced by 2, for example. So if we reduce them all by 2 and cancelling out 2 as a common multiple, these are the numbers that we are left with. And now these numbers are not divisible by any of the numbers as a common multiple, because few of them are odd and few of them are even basically. So we'll have to multiply now. So A share becomes 5 fours are 20, B's become 4 threes are 12, and C share becomes 25 for that matter. And now they were asking A's profit ka share. So A ka profit ka share is 20 parts out of total. So obviously the total is 57 parts. So we know 57 for us, the total profit is 1,14,000 for them. And then they're asking A share. For us, A ka value is 20, is how much? That is X, for example. So if we cross multiply, I will get the answer, and we'll get the answer as 40,000 rupees. So A ka profit is 40,000 rupees out of 1,14,000. So nothing is mentioned, and hence compound partnership is what we are using here as the solving part. I hope you have understood this first question. Very, very basic, very, very straightforward, simple question. Let's do the second one. Quite interesting. It says UVW enter into a partnership with an amount of 5,000 each. After 3 months, you invest an additional 3,000. 3 months later, we invest 4,000, and W at the same time withdraws 1,000 rupees. Profits at the end of the year were 2,31,000. What is W's earning if W is supposed to be given a salary of 500 rupees per month at the end? So because it is 1 year ka duration and W is supposed to be given a salary of 500 rupees per month, and if you remember the note that we had written, the salary is supposed to be subtracted. So 500 rupees per month. So for the entire 1 year, it becomes 6,000 rupees. So that means the profit that we are supposed to divide is not 2,31,000, but it is 2,25,000, because 6,000 salary of W has to be subtracted here. And secondly, From this sort of data, you clearly understand that everybody has invested for different duration for different amounts also. So, for example, all three of them started with 5,000 each, and after 3 months, you invest an additional 3,000. So, that means the investment that you made of 5,000 is only for the first 3 months, and for the remaining 9 months, he has invested 8,000 because he has invested 3,000 extra. And that is what you need to understand here very, very clearly. Look at the language then. 3 months later, which means more 3 months after, which means, I hope you understand, 6 months later, we invest 4,000 rupees. So we also started with 5,000, but only for the first 6 months. Then for the next 6 months, he has invested 9,000 rupees because he's investing 4,000 extra. Basically, they have not said extra, but you have to understand this because they all started with 5,000. And then they are saying W at the same time. That means during V's process, that is 6 months after, W has withdrawn 1,000 rupees. So W did 5,000 for 6 months, but for the remaining 6 months, he has withdrawn 1,000. That means he's left with 4,000 for the remaining 6 months. So these are the numbers now that we have for each one of them basically. And now we'll have to do the calculation for that matter. So let's see how to do that. So first we'll have to cancel out the common multiples. So common multiples, clearly I can see 1,000 can be removed from all the numbers. And because there is plus now, so it should be common among all 6 numbers. So do note all those basic concepts of maths always. Now from all these numbers, I think we can still cancel out from all 6 numbers because there is plus in between. I think we can cancel out 3 from everywhere. So 3 ones are, 3 threes are, 3 twos are, 3 twos are, then again 3 twos are, 3 twos are. Again, we'll have to keep looking if we can cancel out something from the remaining numbers. When you observe them, you will realize there is nothing common left that can be cancelled out from all these numbers now. So that means now is the time where we'll find out the actual ratios basically. So how do we do that? So let's look at the numbers now. 5 ones are 5 plus 8 threes are 24. 24 plus 5 is 29 for U. Then for W, sorry, for V, 5 twos are 10 plus 9 twos are 18. 10 plus 18 is 28. And for W, 5 twos are 10 plus 4 twos are 8. 10 plus 8 is 18 for W. Now let's calculate the profit. So calculate the profit of W. So W's profit is 18 parts out of total. So total becomes 75. 29 plus 28 plus 18. And the total profit was 2,25,000, not 2,31,000. I hope you understand that. So we'll have to do this calculation also. So 75 threesa is 225 and 18 threesa is 54. So this is 54,000, which is W's profit share. Now hold on, do not mark this answer as 54,000. Why? Because you have to read the question very, very carefully. If you look at the question, it says, what is W's earning? Very, very important words. Earnings. And if you remember, he has been given a salary of 500 rupees per month also for the entire 1 year. And his profit is 54,000. So I hope you understand for earnings, his salary should also be added in the earning. So according to me, the answer, because they are asking earning, should be 60,000, which is answer option 1 and not 54,000. Be very, very, very careful before marking any final answer. So what does this variety did is it had different people investing different amounts for different durations, and this is the way you can think about such type of questions. And as usual, before marking any final answer, read the question one more time and then only mark the final answer basically. So this is how we can do that, which is question number 2. Okay, let's look at question number 3 for that matter, which says M and N enter into a partnership. M puts the whole capital of 30,000 on a condition that profits will be equally divided, after which N will pay M an interest on the capital at 10% per annum and will receive 50 rupees per month from M as the salary. What is the yearly profit if N's income is half of M's income? So this income part we'll do it later. The conditions are the entire capital M does it and doesn't do anything. Then profits will be equally divided. So suppose that is X, and N will pay M an interest of 10% for the capital. So 30,000 ka interest is 3,000. So 3,000 N will give to M. So this is plus. And N will receive a salary of 50 rupees per month from M. So 50 rupees per month. So for the entire 1 year, it is 600 rupees. Now we have to find out their profits. Sorry, income. Profit is already given. To find out their incomes. So one simple common sense, which most of the people tend to make a mistake out of it. The income does not include the capital that you have put on. I hope you understand the rules of arrangement clearly. For example, if you have invested 1 lakh rupees in a business, you do not count that as your income. So that part is not there. So if we calculate for M, 3,000 minus 600 is 2,400. The income is 2,400 plus X. Whereas for N, that becomes X minus 2,400. The income basically. And now we have to equate it. N's income is half of M's income. So N ka income is half of N's income. N ka income is this. X minus 2,400 is half of M's income. X plus 2,400. Solve this. This 2 goes here, gets multiplied. So 2x minus 4800 is equal to x plus 2400. This x comes here, gets subtracted. This 4800 goes there, gets added. 2400 plus 4800 is 7200. Again, do not mark this answer. Let's look at the question one more time. What is the yearly profit? If you guys remember, X is the profit that they are gonna get both of them individually. Because the profit was supposed to be divided equally among them. Here it is mentioned. And that is why we have considered that to be X. But now they are not asking individual profit, they are asking company's entire yearly profit or business's entirely yearly profit. Now think about this, if two people are going to get 7,200 each, that means the entire profit has to be double of that, which is 14,400. Answer option 2. So do not mark the answer without reading the question finally one more time. Otherwise you will be so close but still will make a silliest of errors, unfortunately. So be very careful about all such issues basically. So that's your third question, people, from application of ratio proportion. It's still related to partnerships. I hope you are understanding. Moving on, the fourth one. A vessel contains milk and water in the ratio 3 is to 5. When 6 liters of this solution is removed and replaced by water, the ratio of milk and water becomes 5 is to 9. How many liters of the solution was present in the vessel originally is what they are asking. Seems like the one that we have done in the concept, but it is not exactly the same. It is slightly different because of this part. 6 liters of this solution is removed and replaced by water, which means we have added 6 liters of water. Now, what I'll suggest is it is very similar. And how do you solve this in a faster manner? So, one simple suggestion, whatever is this initial removal that they have done, 6 liters is removed wala part, try and forget this for some bit, for one moment, for 1 minute. Forget this has happened. So, for you, the question is a vessel contains milk and water in the ratio 3 is to 5, and it is replaced by water. That means 6 liters of water is added, and the ratio of milk and water becomes 5 is to 9. Now, this becomes exactly the same question that we have done and in the concept. So, you can go back and refer to that. If you remember, the answer of that question was 120 liters. We have done the calculation with two methods, equation and no change component wala. But here, let's look at the question again. They are saying how many liters of the solution was present in the vessel originally is what they are asking. This part is very critical. Now, if you remember, originally whatever was present, we have removed 6 liters of that basically. So because they are now asking the original value, so what we need to do is to get the correct answer, whatever we have removed initially, we simply have to add back in the end part of the answer. So the correct answer for this question is 126, which is answer option 3 according to me, because we are going to add that 6 liters that we have removed. So what you also need to do is the same type of formatting in your brain, which is if nothing is removed, if directly is add, normal question. If removed and replaced by water, then removed wala part initially forget, do it with the normal method, because then it becomes your normal question, and then simply add back whatever is removed earlier basically in the beginning. So answer is 126. Entire solution is as it is, no changes whatsoever. So if you are not still clear with this, go back to the concept wala question, refer this again. You will probably get it right and will understand. And remember the idea, simple addition and simple replacement. Earlier we did only addition. Here we are doing both, removing and adding, which is called for replacement. So this was the fourth question. Let's look at the fifth question, which says a vessel contains milk solution in the ratio 75% milk solution. Sorry, not in the ratio, my bad. A vessel contains 75% milk solution. 20% of this solution is removed and replaced by water, and this process is then repeated two more times. Find the percentage of milk in the solution after the three operations, is what they are asking. So this particular idea is called as concept of wine left formula. There are two versions to it. Let's first try and understand this concept, and then we'll be able to solve this. So there are two formulae for that. One is this one, PF is equal to PI into A minus B upon A, the whole raised to N, or the other version is PF is equal to PI into F1 into F2 into F3 and so on so forth. So this is the formula. Now the first thing that we'll have to do is define the terms so that we can understand the concepts. So PF is always defined as final percentage. PF is defined as final percentage. PI is defined as initial percentage. PI is defined as initial percentage. Then small a is defined as total value. Small a is total value, always 100. The reason is we are going to reset it again and again because removed and replaced by water. So when you reset, it goes back to 100 again. Then small b, it is quantity removed at every stage. Quantity removed at every stage. Small n, number of times operation is performed. Small n is number of times the operation is performed. The second formula, PFPI, remains the same. Final percentage and initial percentage. What is F1 for example? So F1 is fraction left at stage 1. F1 is fraction left at stage 1. So similarly, what will be F2? So F2 will be fraction left at stage 2. What will be F3 will be fraction left at stage 3 and so on so forth basically. So first thing you'll have to do is remember these formulae and their terminologies. So make a note of it very quickly first of all. Then we'll see how to apply all these scenarios and how to solve this question and get your answer. Now, coming back to the question, let's see how do we solve this and how do we get the answer. So let's do it with the first method. So PF is what we are supposed to find out. PI is the initial percentage which is given 75% milk solution. So keep it in percentage only because the calculation will be like that. A is total value which is always 100. B is quantity removed at every stage. So 20% is removed which is 20 and raised to n. Sorry, this is 100. Raised to n is 3 times because 3 operations are performed. So let's do this, which is 75% into 80 by 100. 80 by 100 is 4 by 5 and we have to do 4 by 5 ka cube. So 5 5s are 25, 25 3s are 75. The 4 ka cube is 64, 64 3s are 192 divided by 5. I think 38.4% is the answer for final percentage, which is answer option 4. Using the first method, which is a minus b upon a the whole raised to n. Let's try and understand that using the second method. So PF is again same, which is 75%. But F1 If you remember, we defined F1 as fraction left at stage 1. So for that we need to understand how much is removed. So 20% is removed at stage 1 and 20% is 1 by 5 which is removed. But we are not supposed to find out the removed, we are supposed to find out the one that is left. So if 1 by 5 is left, then obviously 4 by 5 is 1 by 5 is removed, then 4 by 5 is left basically. Similarly, F2 again 20%, that is 1 by 5 is removed. So 4 by 5 is left, and again 1 by 5 is removed. So 4 by 5 is left. So that means we end up getting the same answer with the second approach also. Only change is the thought process or the calculation way is different, but the core idea is the same idea, which gives you the answer basically, which is 38.4 wine left formula used in such kind of questions. So you can remember and then use it, apply it whenever such things are required basically. That's the core philosophy behind it. Now, let's do the next one, that is question number 6 for that matter. It says a vessel contains milk solution 75% and 20% is removed and replaced by water. Then 25% is removed and replaced by water. And finally, 33.33 is removed and replaced by water. Find the percentage of milk in the solution after the three operations, basically. Clearly, wine left, but now comes an important thought process also, which is we cannot use the first formula effectively, because remember that first formula is applicable when you are removing same value every time. Here we are not removing same value every time, we are removing different value every time. So that means second formula is something that is more effective, and which is what we are gonna also do here. So I will suggest something now after this part, that always remember the second formula only, because irrespective whether you remove same values at every stage or whether you remove different values at every stage, second formula is the one that can manage all of that, provided your interpretation and numbers are clear. So PF, final percentage, we have to find out after the three operation. PI, that is initial percentage, which is 75%. Stage 1 F1, fraction removed at stage 1. So we are removing 20%, and 20% ka fraction is 1 by 5. But we are not asking that is removed, the one that is left behind. So if 1 by 5 is removed, 4 by 5 is left behind basically. These things you need to remember now. Then 25% is removed. So 25% the fraction is 1 by 4. And then 33.33 is removed. And 33.33 is 1 by 3, for example. So 25% is removed, which is 1 by 4. So leftover is 3 by 4. And lastly, 33.33, that is 1 by 3 is removed. So 2 by 3 is left basically uh, in the calculation. So let's do the calculation now. 75% into, so 5 15s are 75, and then 4 gets cancelled, 3 gets cancelled, so 15 2s are, that is 30% straight away as the answer, which is answer option 2, for example. So this is how you can use wine left formula for the calculation. So if you are removing different values or same values, second formula is your go-to solution, and follow that also every time, so that you don't uh, miss out on the ideas. Okay, now let's do the second last question, which says 6 liters are drawn from the vessel which is full of wine and then filled with water. Then again 6 liters of the resulting mixture are drawn from the vessel, and then vessel is again filled with water, and the quantity of wine now left in the vessel to that of the water is 144 is to 81. How much does the vessel hold in liters, for example? Now this is also a wine left question, but it's a reverse application of wine left. Why so? Because you are removing 6 liters every time, which is the same value. And just now we saw in the first question, that is question number 5, you can go back and revisit that. Is that if you remove same value 20%, the leftover is also same every time, which is 4 by 5, 4 by 5, 4 by 5 for 3 instances that we have done. And then they are saying after this process is done 2 times of removing 6 liters and then refilling with water, the quantity of wine now left in the vessel to that of water is 144 is to 81. So this is the ratio of wine and water that they have given. But folks, if you remember, we need the fraction of wine that is left. And again, this will come from the concept of ratios. So from the ratio, how do we find out the fraction? So fraction means out of total, whatever is the component. So wine is 144 and total is 225, because 144 wine and 81 water. If we add both of them, we get 225 as the fraction of wine left. Now, one more time here, these numbers 144, 225, clearly they are perfect squares. So stage 1, 12 by 15 must have been removed, sorry, must have been left, and stage 2, again 12 by 15 is left, and hence combining both of them, the final fraction that is left after two stages is 144 by 225. And this will happen every single time in all such instances. Mind you, the numbers have to be squares if there are two steps. They have to be cubes if there are three stages, and so on so forth, basically. So that is what you need to remember. But now what they had done is they had removed 6 liters. This is leftover. Now think about this. If 12 by 15 is left, how much would have been removed? So clearly 3 by 15 would have been removed in stage 1 and stage 2. But ours is 3 by 15, which is 1 by 5 for that matter, if you reduce, and theirs is 6 liters, because they are saying 6 liters is removed basically. So ours is 1 by 5, which is 3 by 15, which is theirs is 6 liters. They are asking how much does the vessel hold. So vessel ka capacity is 1. So 1 is how much? 5 goes there. I think 30 liters, which is answer option 4 for question number 7. Wine left formula, but reverse application of wine left formula. 12 by 15 is left, so 3 by 15 is removed, which for them is 6 liters, and so on and so forth. Slightly better representation than my handwriting for sure. So here is it, if you want to refer it to that solution. Now let's do the next one, which says there are two casks. Second is twice as big as the first one, and the first cask contains whiskey and water in the ratio 7 is to 8. Second contains whiskey and water in the ratio 4 is to 5, and the contents of the two casks are added to the third cask, which can hold thrice as much as liquid, then what is the ratio of whiskey and water in the third cask? Now, here, what you need to understand is the ratios are given for whiskey and water. So, what you need to do is you have to always assume such a number which will be common to all these numbers. So, 7 and 8 is 15 total, and then 4 and 5, the sum is 9. So, we have to take a number which is a multiple of 15 and 9 for that matter. So it clearly is 45. So let's assume that the first cask has a capacity of 45 liter. Then they said that the second is twice as big as the first one. So second becomes 90 liters for that matter. Now we also have to distribute the whiskey and water. So this is 21 liters. This is 24 liters. Similarly, this is 40 liters and this is 50 liter. The breakup of 90 liter in the ratio 4 is to 5. Now what we are doing is we are adding these contents to the third cask which will hold thrice as much as the first one. So third cask should hold three times of the first one, which is 135 whiskey and water. So first वाले से whiskey आएगा 21, second वाले से आएगा 40 liters. फिर वाटर फर्स्ट वाले से 25, सेकंड वाले से 50. If we do that, 61 liter, 74 liter. If we do the total of both gives us 135, which is three times as of that of the first one, which matches. And now they are asking, but what is the ratio of whiskey and water in the third cask? So in the third cask, we have figured out the liters wala value, and because it is ratio, so obviously it has to be reduced to the lowest form. Uh, Unfortunately, we can't reduce these numbers because 61 is a prime number. So clearly, that is only the ratio which is answer option 3 for that matter. So the ratio of whiskey and water in the third cask is 61 is to 74, which is answer option 3 for the eighth one, basically. So don't assume random numbers. You can do it, but the calculation will be complicated. So instead of that, go for simpler numbers, which makes your job easier, and then you get the final answer eventually in the correct manner without complicating the numbers. So, folks, that's it about application of ratio proportion, that is mixtures and partnerships. Make sure you have understood this entirely. If not, go back to this one more time and do it all over again. If you still have any queries or concerns, let us know. We are there to help you. So have a great day. Thank you so much. We'll meet again in the next class.